Welcome. This is a video to show how left ventricular heart failure is created in a cardiovascular simulation model. What you see now is the main window of the software, and inside we find a clinical monitoring window with an ECG, an arterial pressure trace, pulmonary arterial pressure trace, as well as separate left atrial pressures and right atrial pressures, and an oxygen saturation curve. We also have pressure volume loops in red for left ventricle, yellow for right ventricle in the left panel, with a horizontal volume scale and a vertical pressure scale. In the right-sided panel we have atrial pressure volume loops from the right atrium in blue and from the left atrium in brown. We also can study oxygen saturations in various parts of the system. So what we see now is a perfectly healthy person with a heart rate of 72, and we will now modify physiology to create left-sided heart failure. First thing we do is to reduce systolic contractility. And as I go along, you will see that the left heart dilates, as seen in the red pressure volume loop moving to the right. The area of the loop is the stroke work, which is substantially reduced. In parallel with the left ventricle dilating, we will also see the left atrium dilating, and the left atrial loop also moves up, meaning that left atrial pressures are increased. So on top of the systolic heart failure, we also make the ventricle a little stiffer to mimic a diastolic component of heart failure. When I'm doing that, we'll see that systolic blood pressure continues to go down, and the left ventricular loop actually moves a little bit back to the left. So the left ventricle shows less dilatation, but the left atrial loop continues to dilate and left atrial pressures goes up. We will also add some compensatory changes, such as an increase in heart rate from 72 up to 100. Another important compensatory mechanism is an increase in blood volume. We will increase from 5,600 up to 6,400 milliliters. We will then see a slight recovery of blood pressure and cardiac output, but a further increase in filling pressures. So what we see now is more or less a cardiogenic shock state. And I think that's all for this video. Thank you for your attention.